Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we continue our lesson on introductions of scientific programming. So today we are learning chapter 3, which is related to the operation inside scientific programming. Okay, first we need to know what is the objective for this chapter. Okay, so the first objective is to know the three types of operations. So in scientific programming, there are three types of operation, which is statement, functions, and also command. So in this chapter, you will know what is the statement, what is the function, and what is command. All right. And the second objective is to know the three types of statement. So inside statement, there are three different types, which is assignment, repetition, and also decision. So you know how to create and how to design different statement for scientific programming. Okay, the third objective is to understand the operations of arithmetic expression on both matrix and array operators. Okay, so towards this chapter, you will learn how to create an arithmetic expression on the matrix type and also on the array operators type. And the fourth objective is to understand the operations of Boolean expression on both relational and logical operators. So in this chapter, you will also learn about Boolean expression. So what is Boolean expression and how Boolean expression works in scientific programming. Okay, first we will learn about operation. So what is operation in scientific programming? So in operation, if we wanted to initialize any operation in scientific programming, we must have a statement. So the statement will indicate what the variable is all about and how the variable's operation is. Okay, what does the variables do? Okay, so the first part is a statement. So inside a statement, the first one is the assignment. So in assignment, it is used to assign array to a variable using equal operator. So assignment is actually like an initialization of a variable, where a variable will be initialized with an expression. Either it is arithmetic, which is a number, okay, or an array, or a character. So it depends, okay, on your problem, and also a Boolean type. So a Boolean type is actually like a logical input, okay, either it is 0 or it is 1. So the first part of the operation is to initialize a statement with an assignment. Okay, so we need to assign a variable with an expression. Okay, so variable equals to any value that you get or any expression based on your equations. Okay, so the next part of the statement is the operation itself. Either it is repetition. So if you wanted to have your expression or your operation to be repeated, so you need to execute statement specified number of time. You need to use while loop while you are using Boolean operator, or you can use for loop when you are using equal operator. Equal operator is like a number. So if you are using a number, okay, you need to use for. Alright, so if you are using Boolean operator, which is true or false, you need to use while. For example, while it is true, it will execute this, this, and this. And for a is less than 1, less than 3, so it will execute this, this, and this. Okay, and instead of the repetition, you can also what we call conduct or execute a decision. So decision, it is used to execute statement if condition is true using Boolean operator. For example, you are using if condition, if else, if, and also switch case. Okay, so in terms of decision, it will not repeat. Okay, so it will only execute several functions if the condition is true. For example, if a equals to 5, what will happen? Else, what will happen? Okay, so this is an example of the if-else situations. Alright, so the first one is the statement inside operation. So what about if we have lots of statement inside an operation? What do we call it? So when we have lots of statement inside an operation, we will group it out and we will call it a function. So a function is defined as a group of statements that perform a task. Okay, for example, this is the example of the syntax of function. So it will be initialized as the output 1 until output m. So it is depending on your equations, okay? So the output equals to the function name. So the function name that you have initialized, and then inside the function name you will have a bracket which consists of the input, okay, input that you give to the function to get the output, okay? And then from the function you are able to create a command. So a command is a type of function that mostly used to change the environment, okay? For example, if you have a function named input 1 until input n, so if this function will change the environment inside MATLAB, so we will call it as a command, okay? So next is about arithmetic operations. So how we wanted to create arithmetic operation and how we wanted to operate arithmetic operation inside scientific programming by using MATLAB. So let's continue. Okay, so in MATLAB it has two different types of arithmetic operations. So the first one is the array operations and the second one is the matrix operations. So in this chapter you need to know how to initialize and how to use and when you wanted to use array operations or when you wanted to use matrix operations. Alright? So what is matrix operations? So basically matrix operation will follow the rules of linear algebra. Okay, so when you are learning your mathematics, so matrix operation will directly follow the rules of linear algebra. And what about array operations? So array operation will execute element by element operation and support multi-dimensional arrays. So in matrix operation, it only execute functions by following the rules of linear algebra. So later on you will know what are the differences between matrix and array operation and when you wanted to use matrix and when you wanted to use an array operation, because array operation will execute element by element operation, one by one. Alright, so the period character dot distinguish the array operations from the matrix operation. So inside MATLAB, the arithmetic operation of matrix, so the matrix operation will use an expression without dot, but array operations will use an expression with dot. So in the next slide I will show you what are the differences between the syntax that we are using in matrix operation and array operations. Okay. However, since the matrix and array operations are the same for addition and subtraction, the character pairs dot plus and dot minus are unnecessary. So when you are executing the plus and minus expression, okay, adding and subtraction expression in array operation, so you don't have to put dot here. Okay, you can just directly use plus and minus. Alright, so these are the operator types which is used in arithmetic operator inside MATLAB. Okay, so this is basically the algebraic, so the one that you learn in mathematics. So for example, for addition you are using plus, okay, similar with MATLAB. Subtraction you are using minus, similar with MATLAB. Multiplication you are using cross, but in MATLAB you need to use like a star. Okay, so right division you are using the same thing. Left division you are just what do you call need to reverse the locations of variables, but in MATLAB you are having like a inverse parenthesis, okay, inverse parenthesis divisions. And for power is like a the power of b, where a, the size of a is greater than the size of b and b is put upwards. Okay, but in MATLAB you need to create like a this power symbol and b. All right, so this is it is used for matrix operator. What about array operator? So array operator is actually similar to the matrix operator, the syntax that we are using it, but except for plus and minus, for other operators you need to use dot. For example, multiplication, a dot star b, a dot divider b, a dot reverse divider b, a dot the power of b, and a dot transpose. Okay, So this is the other metric operator, which is A colon B and A transpose. So for array operator, what you need to do is you need to just put an extra dot here. Okay, compare it to the matrix operator. All right. So you see here, what is actually the precedent? The precedent is actually the sequence of mathematics or arithmetic expression that you will execute inside the operator, inside the arithmetic operator in MATLAB. So when you see a combining operator inside an expression, the first one that you need to execute first is a transpose. Okay. The second one is the parenthesis. So parenthesis is like a bracket. Okay. And then the third operation that you need to execute first is the power. Okay. From left to right. All right. And then the multiplication and divisions, and then addition and subtraction, and finally you need to execute a colon. Okay, so this is actually a sequence of operation that you need to execute when the operation is combined. Okay, so first, if you have a transpose, you need to execute transpose first, and then parenthesis, and then power, and then multiplication, and then addition, and lastly, if you have a colon, you need to execute the colon at the last part. Okay, all right. So next I will explain it to you what is matrix operator and how does it how you want to design a matrix operator and how you can use matrix operator in solving engineering problems. All right, so the first part is we will take a look at the matrix operator addition. Okay, so this is the first example. So you see here, when we are initializing a variable a with a matrix of 1 by 3, okay, one row with 3 columns, okay, and then we wanted to add this variable a with a value of 5, so you can do it directly. So a plus 5, so it will add 5 in each element of a. Okay, 5 plus 1 equals to 6, 5 plus 2 equals to 7, 5 plus 2 equals to 8. Okay, so the addition with scalar is performed on all elements of the array. Okay, so you see here, the second part is when we have two different two matrix altogether. So this the first example is about a scalar number adding with a matrix. Okay, but the second one is a matrix add with another matrix. Okay, so you see here, two matrices are added according to the corresponding elements of the two matrices, but both matrices must have the same size. So in matrix operator, if you wanted to execute an addition process, you need to initialize a matrix with similar size. But if the matrix is not from the same size, you will not be able to create the addition process. Okay, so you must know that, and you must aware that if you wanted to create or if you wanted to execute addition statement inside the matrix operator, you need to have the matrix A and matrix B with the same size, except for scalar. Scalar is like a single number. Okay, when single number added by matrix, so you can still execute that operation. But if two different matrix size, if you wanted to add, you cannot do it. Okay. Okay, next is the addition of two different matrix size. Okay, so addition between arrays need both arrays to be compatible in size. So in this example, A is not size of 1 by 3 and A is of size 1 by 3 and A transpose is of size 3 by 1 are not compatible. So I'm sure that you already know how you wanted to do transpose, right? Okay, so the transpose will convert column into rows and rows into columns. Okay, so in this situation, okay, you are adding two different matrix A and A transpose with different matrix size. So when you are executing this operation, you will get an error. Okay, so MATLAB will give you an error. Is like error using plus, matrix dimensions must agree. So from this statement, it is sure that if you wanted to do an addition in matrix operator in MATLAB, you need to have two different matrices with the same size, except for scalar operator. Okay, scalar operator is again the single number. Okay, 1 by 1 matrix. So 1 by 1 matrix can add to any size of matrix. All right. Okay, next we are learning about matrix operator again, but for multiplication. So how we wanted to create and how we wanted to design multiplication in matrix operator? So let's take a look. Okay, so this is the example number 4. So in matrix operator, okay, x equals to 2 multiplied by 3 plus 2. So in matrix operator inside MATLAB, you need to use the star. It's like a star symbol in order for you to initialize the multiplication operator. And you cannot do it directly. Okay, 2 in the bracket, 3 plus 2. So you cannot do that, because if you did that, it will give an error. So error, unbalanced or unexpected parenthesis or bracket. Okay, so if you wanted to create or if you wanted to execute multiplications inside MATLAB, you need to use a star symbol for matrix operator. Okay, so the parenthesis alone does not represent multiplication. So in the next example, okay, you see here, you have a matrix A with the size of 1 by 3, okay, and a matrix B with the size of 1 by 3. So right now your matrix is similar size, but matrix operator cannot execute these multiplications because star mean matrix multiplication, A and B are not the correct size for matrix multiplication in this example. Okay, so you need to comply with the requirement of matrix multiplication in order for you to execute matrix multiplications. Okay, so previously for addition, you need to have matrix A and matrix B with the same size, but in multiplication, you need to fulfill the condition of the matrix multiplication. So in this application, the same size of A and B, we cannot multiplicate. Okay, we cannot multiply with each other. So what is the condition of multiplication matrix that we can apply? Okay, let's take a look at example 6. Okay, so in example 6, we can multiply matrix A and B because this is a valid matrix multiplication where 1 by 3 column vector is A is multiplied with 3 by 1 row vector B. So you can, when you see here, okay, in matrix operator, if you wanted to have your multiplications, your rows, okay, so right now we have 1 rows and 3 columns for matrix A, and then we have 3 rows and 1 column for matrix B. Okay, so in matrix operator, in order for you to execute this operation, you must have the equal number of column of the first matrix. So right now we have 3 column of matrix A, and then it must equals to the number of rows in matrix B. Okay, so this matrix A has 3 columns and this matrix B has 3 rows. So in this operation, you can multiply it. Okay, when it has, for example, this one is 3 columns and 2 rows, you cannot do it. Okay, it will give an error. So you must make sure that the number of column on the first operator on matrix A, the one on the left side, must be equals to the number of rows on the right side. Okay, so in the example 7, you see here that in general, the number of column in the first matrix must be equal to the number of rows in the second matrix. Okay, so you see here, this is 2 by 3 matrix and this is 3 by 2 matrix. So the number of column here is 3, and the number of rows in the second matrix is also 3. So you can execute the multiplication for matrix operator, and you need to use the star symbol. Okay, A multiplied by B. Okay, alright, so the column here must be equals to the rows here, the number. Okay, the number of rows must, the number of column must equals to the number of rows. Alright, okay, next is the transpose. So how we wanted to create a transpose in MATLAB? Okay, so the transpose is basically the rows of A becomes the column of A becomes the rows of A transpose. Okay, it just changed one column into one row. All right. So the transpose of a matrix is obtained by interchanging the rows and columns. So in MATLAB, what you need to do is you need to put a apostrophe here. Okay, apostrophe is equals to a transpose operation inside matrix operator. Okay, so right now we are learning about matrix operator. All right. So in example number 9, you see here A is given the matrix of 1, 2, and 3. Okay. And then we wanted to multiply A with A transpose. So when we transpose A, it will become, so this is actually 1 by 3 matrix. And then when we transpose it, it will become 3 by 1 matrix. So A has 3 columns and A transpose has 3 rows. So 3 columns and 3 rows can be multiplied together and you will get a single answer. Alright. So next is the precedence. So which operator that you need to execute first in matrix operator when you have a different expression which is mixed together. So this is the importance of the precedence inside the matrix operator. So you need to remember and you need to understand which operation will be executed first. Alright. So for example here, so we have 2 different combinations, which is multiplication and also divisions. But since multiply and division have the same precedence level, okay, so they are having the same level, so the operation will compute from left to right. Okay, so 5 multiplied by 6 and then divided by 6 and then multiplied by 5. Okay, 5 multiplied by 6 is 30, 30 divided by 6 is 5, 5 multiplied by 5 will become 25. So similar with this example. So because multiplication and division has the same precedence, has the same level of execution, so it will goes from left to the right. Okay, so in example 11, you see here we are combining 2 operations together, which is minus and also the power. So based on the precedence level, the power has higher precedence than the minus. So what we should do is we should do the power expression first. So 4 the power of 2 is equals to 16, and we will execute the negative value of 16 will become negative 16. Alright, so you must know what are the precedence level of each expression inside matrix operator. Okay, so this is the example 12. Okay, so if you wanted to avoid any confusions of precedence, okay, inside matrix operator, you must use parentheses. So the parentheses is the bracket. Okay, so in a matrix operator, the bracket will be executed first after transpose. So if you have a transpose will execute first and then it will proceed by a bracket. Okay, alright, so if you wanted to avoid any confusion, you just put bracket inside the operator that you wanted to execute first. Okay, it's quite simple. Alright, similar with this one. So if you wanted to execute the negative operation first, you need to put bracket inside negative operation and then you are creating the power of 2. Okay, because the parenthesis has higher precedence than the power. Okay, so the bracket will be executed first. Okay, how about the string? Are we able to create string, or are we able to execute any string operation inside matrix operator? Yes, okay, because in MATLAB, each character or each string has its own integer or its own value assignment. Okay, for example, the value of A here has been assigned to number 65 when we convert it into integers. Okay, so when 65 plus 1, it will become 66. Okay, so when we wanted to convert it into character again, so you just need to create a variable z equals to character, y is the integer, so y is equals to 66. So when we are converting a value of 66, it will become b. Okay, alright, because each character inside MATLAB has been assigned a specific integer. Alright? So operation between string and numeric will return a numeric value. Alright? It will not return any string value. Okay, when you are combining together an expression of string. So in terms of string, you need to put the apostrophe on right and left here. Okay, but if you didn't put any apostrophe here, it will not recognize as string, but it will recognize as a variable. Okay, so you need to put apostrophe here, okay, in order for you to initialize it as a string, as a character. All right, so the second example, if y equals to hello, so h has been initialized number 105, 104, e has been initialized a number of 101, L has been initialized as number 108, L also has been initialized as number 108, and O is initialized by the number of 112. Okay, so let me show you. Okay, let me show the MATLAB. All right, so A. Okay, y equals to A. +1. Okay, so in this MATLAB, A has been initialized as 97. Okay, 97 plus 1 equals to 98. So you can see here that in MATLAB, each characters has been assigned different numbers. Maybe your MATLAB version initialize the character A in different number. So you will try it and you can see what are the numbers that has been assigned to your character. Okay, let me put it. Okay, all right, so let me, all right, so next we are learning about array operator. So what is array operator and how array operator will be designed, and how we wanted to design an array operator. Okay, and what are the differences between array operator and matrix operator, and what are the differences? So let's take a look. So array operator, scalar. All right, so first we are learning about the scalar, how we wanted to execute a scalar expression in array operator. Okay, so in array operator, if you have an expression of a scalar, so number 2 is a scalar. Okay, so if you have any operation of scalar in array operator, you don't have to put the dot. Okay, in any expression in array operator. So any operation between scalar and non-scalar can be written with or without the period. Okay, without the dot. You don't have to put it. Okay, if you have a scalar with non-scalar expression, so you don't have to put the dot. All right, but if you wanted to put a dot, it is also okay. MATLAB will also recognize it as a array operator, because actually the way that the mathematics expression do between array and matrix operator of scalar and non-scalar variable is just the same. Okay, next is the array size. Okay, you see here, when A equals to 2, 4, 5, 6 and B equals to 2, 1, 2, 1, so you see here right now the matrix size is similar between A and B. And then for array operator, we can execute a multiplication statement. So you see here, this is the difference between array operator and matrix operator. Okay, when in matrix operator, for array A and array B which has the same size, it cannot do matrix multiplications. But in array operator, if matrix A and matrix B comes with the same size, you can do array multiplication. So you can do multiplication with array of the same size. Okay, so elements in A and B multiplied accordingly, both array must have equal size. And recap, A multiplied by B need the column number of A and row number of B to be equal. So A multiplied by B, it is referred to the matrix operator. Okay, but for array operator, you can multiply two different matrices altogether with each matrix has the same size. Alright, so 2 multiplied by 2 will become 4, 4 multiplied by 1 will become 4, 5 multiplied by 2 will become 10, 6 multiplied by 1 will become 6. Okay, you can have similar matrix size to be multiplied for array operator altogether. Okay, but for array operator, you cannot multiply any matrix with different size. Okay, so A and A transpose are having equal number of elements but not at equal size. So it is actually like the inverse, like the inverse operator of the matrix operator. Okay, because matrix operator can only execute this kind of function, but array operator can only execute this kind of function. What function it is? So for multiplications, array operator can execute the multiplication of array with the same size, but for matrix operator, it can only execute multiplication of a matrix with the first matrix has the similar number of column with the second matrix row. Okay, all right. Next is vectorizing. So what is the definition of vectorizing? Okay, and how we want to create a vectorizing inside the subject and inside the chapter. Okay, so with data in MATLAB constructed as array, a formula can be evaluated for a large set of values at once. Okay, so this is called vectorizing. So actually in MATLAB, when you are creating a formula which the variable inside the formula consisted as an array or a matrix which consists of a large set of values, we call it vectorizing. So any formula in MATLAB that consists of a matrix, we call it vectorizing. So in vectorizing, element by element operation will be used. Okay, so in vectorizing, you need to know and you need to carefully design the formula by defining either you wanted to use the matrix operator or you wanted to use the array operator. So all of those things will be depending on your applications. Okay, so for the information, let's continue. So in example 19, so the questions ask you to let's consider a formula of compound interest as below. Okay, where A equals to invested money, R equals to interest rate, N equals to total year, and B equals to final balance. So the formula is given by B equals to A multiplied by 1 plus R the power of N. Okay, so this is the vectorizing formula. Okay, this is vectorizing, where you initiate a formula which consists of a large set of values. Okay, initially you are initialize A as hundreds, so the scalar value will result be 236.7 if the value of R is 0.09 and the value of N is 10. So for the first part and for the first steps, you only execute one value only. It's like a scalar matrix only. Okay, so we'll get the result of 236.7. But what if you compute this expression for different types of values of A? So it means that you are initializing A as a matrix with different sizes. So initially you only initialize A as hundreds, but right now you are initializing A as hundreds, 200s, 500, 1000, and 400s, which is 1 by 1 by 5 matrix. So right now you are vectorizing. Okay, you are doing the vectorizing operation. Okay, so when you are initializing value of A equals to hundreds, 200, 500, 1000, and 400, so you will get the answer as, so you will get B equals to 236.7, 473.5, 1183.7, 2367.4, 9469.5. So you will get a set of results. Okay, because your input has a set of values. All right, it's not a single value, so it has a set of values. So this operation, we call it vectorizing. Okay, so how does we want to create this expression inside MATLAB? So what codes that we need to use, and what kind of operation that we need to use? So let's take a look. So the MATLAB code, the MATLAB code is as follows. So first, we initialize the value of r equals to 0.09. Okay, you have a semicolon here. Okay, so the semicolon is like a statement that you don't want your value to be appeared inside the command windows. So you need to use a semicolon in your codes. Okay. So, and then we initialize the value of n, which is equals to 10. Okay. So we initialize the value of r and n. And then first thing first that you are doing inside the example, you are initializing only a single set of values of a1. Okay, and then you are writing a formula b1. So b1 equals to a1 multiplied by 1 plus r the power of n. So right now what you are using is when, okay, 1 plus r the power of n is scalar. Okay, because it only consists of 1 by 1 matrix only. Okay, so if you are multiplying, or you are adding, or you are dividing with a scalar number, scalar matrix, you can only use the, what do you call, the star, without any dot. Okay, you can only directly use the matrix operation. Okay, all right, you don't have to use any dot, because you are multiplying with the scalar matrix. Okay, and then you will get this answer. And then you are initializing a2 with 1 by 5 matrix. So 1 by 5 matrix, but this time it is actually multiplied by a scalar number. So any scalar number multiplied by a matrix, so you can just directly use the star, which is the multiplications, because there are no difference between matrix and array operators when you are executing the operation of scalar and non-scalar. So this time this is scalar and a2 is not scalar. So not scalar multiplied by scalar, you don't have to use any dot here. Okay, so you will get this answer. All right, okay, so next example is the vertical displacement vertical displacement problem. So the example 20. Okay, so if a stone is thrown vertically upward, so this is the the engineering problem that you need to solve. Okay, so if a stone is thrown vertically upward, its vertical displacement s after an elapsed time t is given by the formula s equals to gt to the power of 2 over 2, where g is the acceleration due to gravity with a value of 9.81. So the first thing first, you need to initialize g in MATLAB. Okay, so the structure plan for this problem is as follows. So the first one is to assign the data g and t to MATLAB variables. Okay, so we need to initialize variable g and variable t, and then you need to calculate the value of s according to the formula. Okay, so finally you need to create the value of s. Okay, so this is the MATLAB code that you need to execute. All right, okay, so the first one is you need to initialize the value of g, which are given here, 9.81. okay, g equals to 9.81 with semicolon, and then t is equals to, we are using the colon operator because we are vectorizing t for 6 value of elapsed time. So t is time, so time which starts from 0 seconds to 5 seconds. So you are doing t equals to 0 colon 5. So it will create a set of matrix with from 0 to 5. Okay, and then you see here, this is the matrix that the equation that you need to execute. Okay, so you see here, g multiplied by t. Okay, g multiplied by t is the normal multiplication because g is scalar. Okay, and then t is non-scalar. All right, but when we wanted to execute the power, okay, you must use the dot operator. You must use the array operator. Why? Because when t you wanted to execute the power of 2, you see here, t is initialized as 1, 0, 1, 2, 3, 4, 5. And then you wanted to make it the power of 2, therefore it must multiply by the same matrix, okay? Because 1 multiplied by 1, 2 multiplied by 2, 3 multiplied by 3, 4 multiplied by 4, and 5 multiplied by 5. So this operation only can be executed by array operator, okay? Therefore, you need to put dot here. So dot the power of 2 and then multiplied by, and then divided by 2. Okay, this is why you need to put the dot here, because you are executing the power of 2 by using the array operator, okay? Because when you wanted to make the power of something, you are multiplying the matrix with similar size. So you need to put dot here, okay? So next example is the volume of cones, okay? So example number 21, all right? So suppose the diameter and height of a cone is d and h respectively. Then the volume V of the cones can be computed as, so this is the formula that has been given, V equals to 1 over 12 pi d to the power of 2h. So if you have 5 different sizes of cones and want to calculate their volumes, in most programming language you need to set up a loop where d and h are constructed as vectors. So in general programming, okay, in general C programming, in order for you to calculate a 5 different size of cones, you need to create a for loop. So those loops, actually it will consume some computation and some time, okay? You will waste quite some time, okay, to execute a loop, but because you need to finish one operation and then do another operation at the different time. But in scientific programming, you can just do it once, okay? You don't have to do any loop because you are initializing a variable as a matrix, okay? So by using array operator, you can avoid the loop and calculate all the volumes at once. So this is one of the advantage of scientific programming compared to other types of general programming, okay? So for some values of d and h, the MATLAB code will be as follow, okay? So you see here, you are initializing a value of d with a matrix of 1 by 5, okay, 1 rows and 5 columns. And h also you are initializing like 1 rows and 5 columns. So d and h has the same size, okay? You must remember that, okay? You must know that, okay? So when the variable has the same size, so what kind of operator that we need to do? Is it matrix or is it array? Okay, so you need to know how to choose the operator, okay? So this is a formula as follows, okay? I think this is a typo here, okay? Actually this is 1 over 2 if I'm not mistaken, all right? It's not 12, okay? So 1 over 2 multiplied by pi. So in MATLAB, the pi is initialized as pi, okay? This is a constant that we have learned in the previous chapter, okay? 1 over 2 multiplied by pi and then multiplied by d. As usual, if you wanted to do the power in MATLAB, you need to put the dot, okay? If you wanted to do the power of matrix, okay? If your variable is a matrix and you wanted to do the power, okay, you need to put the dot, d dot power of 2, and then because d and h has the same size, you need to choose the array operator. So you need to put another dot here multiplied by h, because array operator can execute the multiplication of the same array size, okay? All right, so you will get this kind of answer, all right? Okay. Okay, next is the complex number arithmetic. So what is a complex number arithmetic? Let's continue. Okay. So, complex number are numbers that consist of two parts, a real number and an imaginary number in the form of a plus bi. Okay? And a and b are real numbers and I is the imaginary component, where I is equals to square root of -1. Okay, so in MATLAB, I character is introduced as the imaginary part of a complex number. Okay, so for complex matrices, the operation transpose and dot transpose behave differently. So what are the difference between transpose and dot transpose? Let's take a look. Okay, so the transpose operator is the complex conjugate transpose, where the signs of imaginary parts are changed, where the sign of dot transpose operator does a pure transpose. So it just did a pure transpose. It doesn't change any sign of imaginary parts of the complex number. Okay, so let's take a look at this example. So right now you have a matrix with a complex number of A. Okay, you have 1 plus 1i, 2 plus 2i, 3 plus 3i, and 4 plus 4i. And then the first operator that you did is A transpose. So this is the complex conjugate transpose. So what it did is that it will do a simple transpose. Okay, 1 plus 1i and 2 plus 2i will be moved into a row in one row. Okay, and then it will change the sign of the operation. So the plus will become minus, or if you have minus, it will become plus. So it will change the operator, okay, for A transpose sign, okay, without any dot. Okay, it will compute a complex conjugate transpose. And then when we execute a syntax of A dot transpose, so it will execute a simple or a general type of transpose, where it will only move the different column into different rows. Okay, 1 plus 1i, 2 plus 2i in a row, it will move into different rows, 1 plus 1i and 2 plus 2i, without changing any sign of the operations. So you need to use dot transpose. Okay, so this is the general transpose, and this is the complex conjugate transpose. Okay, next we take a look at the Boolean operations. So what is the Boolean operation inside scientific programming, and how we wanted to use Boolean operation in scientific programming? So let's continue. So Boolean algebra is a mathematical operation that return a logical value, which are either true or false. So in MATLAB, a true operation is initialized as 1, and false operation is initialized as 0. Okay, thus in programming language, the assignment from Boolean expression will return a logical data type. So when you are using a Boolean expression, it will return your variables into a logical data type. So it only consists of two values, 1 or 0, true or false. Okay, so there are two data types of Boolean operator in programming languages. So the first one is the relational operator, and the second one is the logical operator. Okay, so later on we will take a look at what are the relational and logical operator inside Boolean operator. Alright, so the common usage of Boolean operators are, the first one is the application of the Boolean operator is to identify a particular element from an array. Okay, for example, we have an array. Okay, we want to detect the elements which is greater than 5. So we can use Boolean operator for this kind of functions. Okay, so the second one is describing decision and repetition statement. Okay, so the second usage of Boolean operator we will discuss in the next class. Okay, where Boolean operator is used to describe a decision. Okay, if something Boolean expression, it will become and it will execute this function, this function, this function. Okay, all right. So this is the relational operator. Okay, so the relational operator, these are the list. Okay, it has less than or equal, equal, not equal, greater than or equal. Okay, so this is the logical operator, and, or, and not. Okay, I'm sure that the logical operator, you are also learning this operator inside your digital electronics subject. Okay. Okay, and then we'll take a look at the precedence. So which statement will be computed first for Boolean operator? Okay, as usual, first is the parenthesis, next is the power or transpose. Okay, so in Boolean operator, transpose will be executed at number 2. Okay, so in a matrix or array operator, a transpose will be executed first and then the parenthesis, but in Boolean the parenthesis will be executed first. And then the third one is not, and then multiply and divide, and then addition and subtraction, and then colon, and then relational, which is here. Okay, less than, equals, equal, no equal, greater than. Okay, and then an operator, and then or operator. Okay. All right. Next is the logical value. Okay, previously I already told you the true is initialized as 1 and the false is initialized as 0. Okay. All right. Okay, this is the truth table for logical operations. Okay, suppose you have input A and input B. So if input A and input B is both are zeros, so the end when we are executing the Boolean operation of A and B, okay, any elements that have 0 here, if one of the element have 0 here, the output will become 0. Okay, so A0 B1 it will become 0, A1 but B0 it will become 0. Okay, but if both are equals to 1, so the output will become 1 for AND operator. Okay, next is OR operator. So for OR operators, if any value contains 1, okay, for example, this one 0 1 1 0 1 1, so one of the elements contain the number of 1, the output will become 1 unless both input is 0. So when both input are 0, the output will become 0. Okay, and then the third one is not A. So you see here, this is A. Not A is like the inverse of A. So as you all know, the Boolean expression only have two numbers, either 0 or 1. So when it is not 0, it will become 1. When it is not 0, it will become 1. When it is not 1, it will become 0. When it is not 1, and it will become 0. So not is like an inverse of Boolean expression. Okay. So if the input is numeric data type, all non-zero values will be assigned as logical 1 and 0 value as logical 0. Okay. So for example, if you have an input of matrix with number, okay, so if the elements inside the matrix is a number except 0, it will be automatically assigned as logical 1. Okay, for the numbers which is equals to 0, it will automatically initialize as logical 0. Okay, so next we will take a look at the relational operator. Okay, so this is the example number 23. All right, so you see here we initialize the value of A equals to 5 and B equals to 10, and then C is the relational operator of when A is greater than B. So you see here, does A is greater than B? 5 is greater than 10? No, right? 5 is actually less than 10. So since A is greater than B is wrong, then the output is 0. So it is a false statement. Okay, so it is not correct. Okay, 5 is not greater than 10. Alright, so the output will become false and it will become 0. Okay, next we'll take a look at example 24. Okay, so example 24 is it's like a matrix which contains numbers. Okay, A is a variable which contains a matrix with different numbers. Okay, you see here, and B is a numbers which is small. So we wanted to compare A and B. Okay, so C is actually a comparison between A is less than B. So does 1 is less than 4? Yes, it is correct. So it will return 1. Okay, next, does 4 less than 4? No, it is not correct. Therefore, it will return 0. Okay, does 5 less than 4? No, it is incorrect and it is false. So it will return 0. Does 2 is less than 4? Yes, it is correct. So it will return the number of 1. Okay, so it will execute a relationship between A and B. Okay, A is less than B. When the statement is true, it will return 1. When the statement is false, it will return 0. Alright. Okay, so next is statement D. Okay, statement D is equals to B less or equals than A. Okay, we see here, is 4 is less or equals to 1? No, right? So it will become 0. So does 4 is less or equals to 4? Yes, because 4 is equals to 4, therefore it will return 1, which is true. And then, does 4 is less or equals to 5? Yes, 4 is less than 5, so it will return 1. And does 4 is less than 2? No, it is false. 4 is not less than 2, so it will return 0 as indication of false statement. Okay? So next is the logical operator. So how you want to design and how you want to use logical operator in scientific programming. Okay, so let's take a look at this. Okay, so you are initializing a value of A with 1 by 5 matrix and value of B of 1 by 5 matrix, which contain logical value 0 and logical value 1. Okay, so C, you initialize it as a logical statement of A or B. Okay, A, this is the syntax of OR. Okay, A or B. So it means that if any value of A and B contain the value of 1, it will return 1. Okay, but if both value of A and B is equals to 0, it will return 0. Okay, it is simply like that. So you see here, 1 or 0, it will become 1. 0 or 0, because both are zeros, it will become 0. 1 or 1, so it will become 1. 1 or 0, okay, one of the elements contain 1, it will become 1. One of the elements contain 1, it will also become 1. Alright? Okay, so this is the example number 26. This time, the variable that you initialize contain a number. So it doesn't contain on any Boolean expression or Boolean number, okay? Boolean number is like 0 and 1, but this time you have number of 1, number of 4, number of 5, and number of 2. Okay? So, you initialize the next statement B, okay, equals to A, this number, this matrix, and with 0, 2, 4, 0. So you see here, okay, as I said before, if in MATLAB, okay, any numbers which is not equals to 0, it will be automatically initialized as logical 1. So it will become 1, 1, 1, 1, and the matrix B will become and the matrix this matrix will become 0, 1, 0, 1. Okay, so first we are using an operator. Okay, so right now 1 and 0, it will become 0. Okay, and then the second one is 4. 4 will become 1 in logical, okay, because it is a number not equals to 0. Okay, so 1 compared with 2, 1 compared with 1, okay, because 2 when converted into logical, it will also become 1. So 1 compared by 1, 1 and 1, it will become 1. Okay, and the second one is 5. 5 is a number and it will become 1 in logical. 4 is a number and it will become 1 in a logical. Okay, so 1 compared by 1, it will become 1. Alright, and 2 will become 1 in logical. So 1 compared by 0, it will become 0, because 1 and 0, okay, and it's like a multiplication. Okay, 1 multiplied by 0, it will become 0. 1 multiplied by 1 will become 1. Okay, so for operation on numeric data type, all non-zero values will be assigned as logical 1 and 0 values as logical 0s. Okay, so when we have a matrix with a number, if the number is not equals to 0, it will automatically assign as logical 1. Okay, if you have a value of 0 inside a matrix, it will automatically assign as logical 0. Okay, okay, next is the precedent. Okay, so what about if you have the combination of relational operator inside MATLAB, inside your expression? Which one you want to do that first? Okay, so you must remember the precedent of the logical and also the relational operator expression. So you must know and you must remember the sequence. Okay, so for example, we have two matrices here, matrix A and matrix B. Okay, which matrix A equals to 1, 6, 5 and matrix B equals to 3, 4, 5. Okay, right now you have the expression, the relational expression of A is greater than B and not equal to 5. So which operation will be executed first? Okay, so based on the precedence level, those what we call a relational expression falls into the same level. So what you must do is you must execute from left to right. Okay, so right now we are comparing A is greater than B. So is A is greater than B? No, so it will become 0. So 0 is not equals to 5. Yes, 0 is not equals to 5, so it will equals to 1. 1 is true statement. Okay, next, does 6 is greater than 4? Yes. So when it is yes, it will become 1, number 1. Okay, so does number 1 is not equals to 5? Yes. So it will return the value of 1. Okay, so next is, does 5 is greater than 5? So it is false, so it will return 0. And then, does 0 is not equals to 5? Yes, 0 is not equals to 5. Okay, so when this statement is true, it will return 1. Alright, so similar with this, this next example shows it's like a reverse, okay, reverse statement of the first expression. Okay, first we compute the similarities first. So A is not equals to B greater than 5. Okay, when we execute this statement, 1 is not equals to 3. Yes, so it will return 1. So 1 is greater than 5? No, 1 is not greater than 5, so it will return 0. So similar with other statement. Okay, so in the next example 28, so what are the precedence of the logical operator? Okay, so the illogical operator, it has its own precedence level. Okay, so you must know and you must remember, and or is and first or operation first. So in this example, and has higher precedence than or, so and statement will execute first. Okay, so A equals to 1 and 0. Okay, 1 and 0 equals to 0. Okay, because 1 multiplied by 0 equals to 0. Okay, 0 or 0, obviously it will become 0. Alright, and then the next one is A equals to 1 or 0 and 0. So from this statement, we need to execute the AND operation first. So we need to execute 0 and 0 equals to 0, and then 0 or 1 will be equals to 1, because any number, when you want to execute OR statement, if one of the number has the value of 1, it will become 1. Alright, okay, mixed operator. So in decision and repetition statement, which will be discussed in the next chapter, mixing the relational and logical operator will be very useful in having more than one condition at once. Okay, so when you are solving the engineering problems, you are required to mix the relational operation, logical operation, decision and repetition statement all together. Okay, basically we need to combine the array operator, matrix operator, relational operator and logical operator in order for us to execute and solve the engineering problem. So you will learn how to mix those operators in the next chapter. Okay, but for now we will discuss on how those two can be mixed into single expression. Okay, so this example shows how you wanted to make logical and also relational operator all together. Okay, for example, if you have a set of value of A, okay, 1 4 5 2 9 2 5 7, okay, and then you wanted to find the element of A where A is greater than 2 and A is less than 8. Okay, so it means, what does it mean by this operator is you want to find the elements of A from value of 3 to 7, because you doesn't have any equals value here. Okay, you only have A is greater than 2. Okay, it means that the number is greater than 2 is 3 4 5 6 7, but it is less than 8. Okay, it is greater than 2 and it is less than 8, so the number will come between 3 and 7. All right, so when you are running this operator, so it will detect each number inside variable A, which is from 3 to 7. So if the number is from 3 to 7, it will return as 1, because it is a true statement. Okay, you see here, 1 is not between 3 and 7, so it will become 0. 4 is between 3 and 7, so it will become 1. 5 is also between 3 and 7, so it will become 1, and so on. Okay, so this is how you can combine the relational and logical operator to solve your problem, okay, to solve the engineering problem. Alright, so this time mix with arithmetic operator. So how we wanted to mix it with arithmetic operator? Okay, so this is the example number 30. Okay, so you see here we have two different variable, okay, a and b, that we initialize as a matrix. Okay, and then c equals to a or b minus 3. So which operator that we need to execute first? Okay, so when both arithmetic and boolean operators are used in single expression, the output data type depends on the last operator executed. Okay, so in this operator we will execute the arithmetic operators first. Okay, so right now b minus 3. Okay, so we will execute the arithmetic operator first, where the arithmetic operator is b minus 3. So b will minus 3, it will become negative 2, negative 3, 0, negative 1, and negative 3. Okay, so a or any value which is not equals to 0 will become 1. Okay, sorry. And then d also, if you wanted to execute the relational or logical operator first, what you need to do is you need to put a bracket. Okay, and then it will execute the relational or logical operator first, and then it will execute the arithmetic operations. All right, so you need to put a bracket. Okay, so next, this logical and relational operator, it is also used to identify elements. Okay, so this is example 31. All right, so in relational operator, a relational operator can be used to identify elements based on some condition. So in this example, b has the information on which elements are required. Okay, so first, this rand is actually random integer from 1 to 15 with matrix size of 3. Okay, so we are creating a random integer, okay, with 3 by 3 matrix with number from 1 to 15. Okay, so it will distribute a random number. Okay, so right now we wanted to detect the number inside the variable a which is less than 9. Okay, so we can execute this expression, b equals to a is less than 9. So it will convert it into logical operator, where the number from 0 to 8, it will put it as 1. Okay, 6 will become 1, 3 will become 1, 1 will become 1, 5 will become 1, and 1 will become 1 because it is less than 9. And the other is from 9 to 15, it will become 0. Okay, all right. And next, what we wanted to do is we wanted to list out what are the elements, okay, what are the exact numbers which is less than 9 inside a. So what we should do is we just need to do the indexing. Okay, a in bracket b. So it will list out all of the numbers inside a which is less than 9. All right, okay, so in this example, b has the information on which elements are required. Then by using logical indexing, elements of a which are less than 9 can be extracted. So we can extract the elements which are less than 9, okay, by using this syntax. Okay, note that when no equal operator represent, MATLAB automatically assign the value to a variable named answer. So when you are not assigned any variables, okay, it will automatically give your statement as the ans, which is the answer. Okay, so next is identify element by mixing relational and logical operator. Okay, so this example is actually similar to the previous example, but this time we are combining relational and logical operator altogether. Okay, so as usual, we are initializing a random number from 1 to 15 with matrix of 3 by 3 matrix. Okay, and then what we did is we initialized a variable b, which is the indexing. Okay, which we wanted to detect the number of elements inside variable a which is less or equals to 4 or which is greater than 11. Okay, so the number inside variable a which is from 4 to 0 or which is less than 4, okay, from 4 to 0, or from 12 to 15, it will become a true statement here, okay. So 12 is less than 11, and also 12 is less than 11, so it will become 1 here. And then 3 is less or equals to 4, so it become 1 here. 1 is less or equals to 4, and 1 here is also less and equals to 4, okay. 1 is less or equals to 4 here, 1, okay, and it will become 1. All right, so this is the indexing that you get. And then if you wanted to list out, as usual, you can do it A in bracket of the indexing, okay, and it will list out all of the elements which is less or equals to 4 and greater than 11 in the variable A, okay. So it will become 12, 12, 3, 1, 1. All right, okay. Okay, so I think that's all for today's class. So I hope that you will be able to understand what are the operation which is available inside MATLAB and inside scientific programming, and you can do some of the example, okay, inside MATLAB, okay. And if you have any questions or any inquiry, you can just ask me in the WhatsApp group, okay. That's all for today's class. Thank you.